Okay, welcome back. So that was our look into period. Now we're going to have a look at the other important one that we deal with here, which is the notion of a shifter. Now we're familiar with shifting. We've seen shifting happen already. In this case here, we've now got this shift or displacement. So I'm going to refer to as displacement. Sometimes it's referred to as a shifter, a displacer, or a phase change. All of these terms are reasonable, and so they get emphasised one way or the other, depending on the context. So a phase change, and a phase change will have a shifter. So if we compare it to, now look what we're talking about here, of course, is our familiar bits and pieces. So there's our y equals x, and if we want to shift it, we would have it shifted across to 2. Okay, so that would be a change of y equals x. Now the way it would manifest itself in the linear is y equals minus 2x. So it'd still be positive x minus 2. So that has the effect of that. For y equals x squared, if we're going to shift this y equals x squared, we know that it sits here like this. And we know that if we do a perfect square one side or the other, we'll get a shifter. So these will be shifted across like this. And so that displacement, that phase change in the HSC, they call it dilations, don't they? Dilations. And those kinds of things, so which is which, it's the opposite. So the plus would be out the minus, and the minus would be the plus. So we can have our displacements also for our waveforms. So what does that look like? It's not always obvious what that might be. So if we take our sine wave again and just do our lovely sine wave, if we think about that sine wave cyclically occurring, what this will have the effect of is if we shifted it by some amount, let's say we shifted it by pi on 2, it has the effect of following through, okay, and going down, and it has the effect of moving the sine wave along. Now, I've made no reference to earlier or later, but we'll discover that as we look at a particular example. So let's do that. So here we want to look at the shifter and consider that. Now, just if we have a look at this idea here, sum C, for C is positive, okay, for C is positive, to the left, if C is positive. Now, if C is negative, we'll shift to the right. So Mathland, that's how we would say C is negative. So the result of that will be shift to the right. So we need to just keep that in mind. The fractional idea and the integer idea, not so much, but the plus minus of the shift. Okay, so we need to keep that in mind, because if we're plussing a minus, that'll look like a minus, etc. Okay. All right. So, and the other thing that we want to consider is the displacement is with the effect of C in algebraic terms is minus C on B. So we'll just give that result at this point, minus C on B. Okay, so what we're doing is moving it along. So let's use this information to help us develop a response to a particular question. Okay, so in this case here, we've got an amplitude, and the amplitude is the magnitude of A. So there's the language that's we're getting used to. Amplitude, which is the magnitude of the coefficient A, which sits at the front. Okay, so in this particular example, the magnitude of the coefficient that sits in the front is 1. Okay, the next thing we've got is the period, and the period is given by an equation. And the period, now I really am spending the time here to try and help you understand that you can't shirk this. So please don't try and skip into the solutions simply by doing this. Okay, so in this particular example, A is 1, B is 1, and C is this one. Okay, so here this is 2 pi on B, which is 2 pi on 1, so not too complicated, which is just 2 pi. So that's good. All right, and then finally we want the displacement. The displacement, otherwise known as a phase shift, and the phase shift is minus C on B. So in this case here, we have minus pi on 4 divided by 1, so watch out for that, because if that's a fraction, there'll be more to do. So we've got minus pi on 4, so we're going to be going backwards. Alright, so let's put this together. Let's do a sketch of this particular one. Let's do it in comparison to a normal cos waveform. Just sketch your comparison waveform. I encourage you to do that as a matter of course, because it doesn't take long. Okay, you know that that's 2 pi. You know that that's pi. You know that that's plus or minus 1. So how easy is that? That's no different to doing the setup for the comparisons when we do all of these guys. So what's the diff? Nothing. Okay, it's a matter of academic discipline that you give yourself the opportunity. Alright, so if we're having the same cos, the same period, the difference is pi on 4. So if we come here to pi, and we just divide pi into 4s, so there it is, pi on 4, and we see that if we come to plus 1 of those pi on 4s, that's going to be our starting point. And in actual fact, it's the negative of one of those, isn't it? So we actually have to continue this on. And whatever that gap is there, we're going to extend it to there, because that's minus pi on 4. That's minus 1/4 pi. Minus 1/4 pi. So in actual fact, that's the starting point. Okay, the starting point actually begins there. So what we find is that when we implement this now, we'll be starting up at 1, and we'll be following this down, and everywhere you've got your crossover point, it'll be earlier by 1/4. Okay, so earlier by 1/4. That's all it is. So pi on 2 is our regular part. Our half of pi on 2 is pi on 4. So we're going to come down, pi on 4, go. Zoom. Okay, and then we're going to follow this down, and instead of being at pi, we're going to be earlier. So there it is. are going to be earlier. So we swoop down here, earlier. And instead of being 3 lots of pi, or 3 lots of pi on 2, okay, it's going to be a quarter pi earlier. So it's going to come up and advance. Okay, and instead of being 2 pi, it's going to be a quarter pi earlier. It's going to finish there. It's going to come up and finish there. Okay, so if you learn to develop your intuition, you'll find that this is fairly straightforward. Now, you can do the tables and the things if you want to. There's probably no real harm in doing that because you've got to get your bearings. Okay, but the key thing was to develop this baseline, to understand the positive minus, and to give yourself your divisions. Okay, so I've effectively made a table by all of my dotted lines. Okay, so this is 0, so that's pi on 4, and so on and so forth. Okay, so you can go through here, this division here is pi on 4, pi minus pi on 4. So if you want to get the table entry, you can just do pi minus pi on 4. Okay. So pi minus pi on 4, which is this line here, which is where this max occurs. Okay, if we do the thing that we do, we're very good at that. Same family, 4 pi minus pi is 3 lots of pi on 4. Oh, so that's 3 lots of pi. That's where negative 1 is occurring. So you can do that same intuitive balance, just sketching along, plotting your points. If you want to put it in a table then you can put it in a table. Okay, that's no problem. You can do your 3 pi on 4, and at 3 pi on 4 we've got negative 1. Okay, then you can do your minus pi on 4. We have a 1. Or you can put it in pairs, ordered pairs. Okay, in terms of x and y, if you want to do it that way. So either way, just build up your intuition. I think sometimes just jumping straight to computations is not necessarily the best thing. So try and do a geometric interpretation before you build up your table. I'm happy for you to do the table, of course. There's no problems there at all. Let's see if we can do that again with another example. But before we do that, let's compare. So we're going to do cos. And we're going to do, what was our one? Just x plus pi on 4. So we're just going to do, take that away. Go to cos. Our 3 was not there, but we had plus pi divided by 4. And we didn't have a final comparison. Put that in the next one. So let's have a look at cos plus pi on 4. Oh, look, there's our normal cos, and it's earlier. So use that language, please. It's earlier. Okay? So comparing it to, because that'll come up, it's earlier. It's arriving earlier at its negative. It's arriving earlier at its endpoint. Okay? So try and get earlier and later in, because they will help you if you're doing any kind of waveform analysis. Alright, I think we've got enough time to do another example, so let's do another example. And just use the same things. So we've got A, seeing a bit more shortcutting now, aren't we? B, because we're getting so good at it. Now this will be a bit tricky because the displacement or phase shift, we need to be careful here, okay, is minus C on B. So we'll need to be careful. So we've got minus, now this is minus, so we've got minus pi on 3. And B is not 1 anymore, B is 3. So what we've got here is plus pi on 3 divided by 3, all coincidental that they're the same, which is pi on 3. This is the most important steps. Not you jumping to conclusions, but doing your setups. So that's divided by 3. And so that's pi on 3 times 3 over 1. Okay, so we're going to see that they're going to cancel, and we're left with a displacement of simply pi. A displacement of simply pi. Now, have I done that correctly? No, I didn't, because I didn't flip it. So there you go. It pays to be observant, doesn't it? Pays to be observant. That's 3 over 1. 3 over 1, mister. So that's times 1 over 3. So the displacement's pi over 9. Get your facts straight. Get your facts straight. Pi over 9. Alright, the other thing we want to do is consider the period. P is 2 pi divided by 3. So using the nomenclature that I prefer to use, it's 2/3 pi. So we've got the two most important pieces of information. So it's finishing at 2/3 pi, so it's faster, and it's displaced by pi on 9. So let's do our setup. So we can do our setup, put in a lovely long sine wave, that comes down and repeats. So we'll just keep that going on. Out here, comes down. So we know that that's 2 pi. We know that that's pi. We know that that's 1. And we know that that's minus 1. So that's our comparative information. So let's change the graph to our different colour. And our displacement is 2. So we're going to come up here to 2. And we're going to come down here to minus 2. Alright, the next thing is that we're finishing at 2/3 pi. So we can take pi and divide it up into thirds. 1/3, 2/3. So we're finishing here. We'll have one complete cycle done here. And the last thing to do is to consider pi on 9. So now I'm just going to change the colour there to make it a bit easier to see. But essentially now I can't do it halves because 9's an odd one. But if I just hazard a guess, so 9, I might have to erase them. You can do a calculation if you want to, a table. Happy for you to do that. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I do have to erase them because I was just not quite long enough for that graph. So I need to be a little bit longer. Okay, because I put 10 in. So I need to be a little bit bigger. And so I'll do that a little bit bigger. So last time I went about here. So I'll go here. And double that's there. Again. And again. 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 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm kind of finding the way, but I don't mind this. Look, I don't mind this because I can do the computation. I don't want to do that. I want to build my intuition. Okay, I want to build my intuition. So we're going to have it as 9s. Divide that into thirds. Try that. 1, 2, 3, 5, 6, 7, 8, 9. That's better. It's a little bit skewed. Could redo it, but I'm not going to. I'm just going to let it sit like that. That's fine. Okay. And what about the other third or something? Okay, so now I've got my ninths. So I'm going to do it in red again. Yeah, I'm still in red. So that's good. Now, what are we going for? Pi on 9. So we're taking this point here as the delay, the starting point. Okay, so remember, we're going to compare it against this one. So that's our pi divided by 9. So what we're doing is that we're starting. Okay, pi divided by 9. This is our finish point. This is our middle division. So this is our middle division. And we've also got half of that. Halfway there is approximately there. And halfway there, approximately there. So it's a sine wave. So we're going to start here and swoop our way up. And swoop our way down. And swoop our way all the way down. And swoop our way down. Okay. So what we've got then is our ability to work on our period. Okay, this is 2/3 pi. There's pi. So our halfway point, half of 2/3 will be 2/6, which is 1/3. So this is pi on 3. So you can build your table up just as easily. See, some people will want you to build the numbers first and then plot the graph. I'm doing it in reverse. Okay. Now, half of pi on 3 will be pi on 6. That's pi on 6. That's happening at pi on 6. So that's all the way down there. Okay. This one here is half, well, pi on 3. It's the same thing. Now, notice we've got all the 3's and things. We can change all of these so that they're common. You can do that. Okay. It's not a big deal to change them so that they're common. Okay. So they're all in 6th, or you can make them in 18ths, or whatever you want to do. You just got to learn to recognise that. Okay. So we're going to add pi on 6 to pi on 3, and that'll give us this point here. So pi on 6 to pi on 3. So pi on 3 plus pi on 6. So it's 2. So it's 2 pi plus pi is 3 pi on 6, which is pi on 2. You could have mentioned that. Pi on 2 is half of 1. Okay, so get your picture sorted out in your head, I think, is a better alternative, using these two very important pieces of information, and then you can go ahead. And I mean, that's not symmetric, so you'll have to forgive that. But there you go. All right, so let's just quickly put in 2 sine 3x minus pi on 3. So we'll have our comparison, and we'll have 2 sine 3x minus pi on 3. I think that's what it was. Let's check that. 2 is 3x minus pi on 3. And so does that look like ours? Brilliant. Okay, so we've got ours starting a little bit later. Yep, tick. Starting a little bit later and finishing earlier. Okay, so very good development. And just use these basic pieces of information first to get yourself started. Do a sketch, do a comparison. I would encourage you to do that, rather than just going off building up all your complicated values for where they land. Now what we can do, we can take all of these values and normalize them. And by that, I mean we can put them all to some common denominator. Okay, so this could be, if we wanted to make it all on 18ths or 6ths, this is going to be 2 pi on 6. This will be 4 pi on 6. Okay, this will be 3 pi on 6. There it is there. So we can put them all in terms of pi on 6. Just read the question and see what the question says and take it from there. All right, in a moment we'll come back and have a look at the identities, and we'll do that in another video. Back soon.